Hello everyone. I welcome you all to this channel. And in today's class, we would be discussing about permutation. Now, many of you would have come across this problem and you will be wondering how to do this question with repetition, without repetition. So that is what we'll be discussing today. First, a quick overview about permutations. So permutation means you have an object or letters, as so we'll be discussing in this question here the way of arranging the letters. Okay, and the order is very important. Okay, so for example, I have STAR, star, right? What are the different ways in which I could arrange this letter, right? So TARS, with or without meaning. So there are so many possible ways. So how do I find it? That is using the concept of permutations. So permutation means arrangement. So if you have four letters, then the number of ways in which how many words could be formed by interchanging the letters would be 4 factorial. It's just how many letters we have. We'll just count it and we'll just factorial it. So one formula that you need to learn in permutation is NPR, where N is the total number of objects and R is the selection, which is given as N factorial divided by N minus R factorial. If you just know this one formula in permutation, you can do any question. Okay, let's try a question here. Take a look at this question. In how many of this distant permutation of the letter Mississippi to the four I's not come together? So first of all, we're talking about distant permutations. How to do this? First, let's take out this word and see how many letters I have. So I have the letter M, distant letters, I, S, and P. These are the four different letters that we have. And then how many times does this letter M occur? It occurs only once. What about I? I occurs 4 times. And what about S? S also occurs 4 times. And P occurs 2 times. Now, generally, they're talking about distant permutation. So first, let me see how many times, right, does this letters get permutated. So count and see how many letters we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So how to find the number of letters, which is I have total 11 letters. So 11 factorial divided by. So now I have four I's, right? If I have M, I, and I, this is the first I and this is the second I. M, I, and I, this is the second I and first I. They both convey the same meaning. So I need to ignore those parts. So that would be, if you have four I's, that would be 4 factorial. I have 4S, that means another 4 factorial and 2P. So this is our answer. Now you can just expand it and simplify this, right? So 11 factorial will be 11 into 10 into 9 up till 1. So if we simplify this, that will be equal to 34,650. So these are the distant permutations. Okay. Next, they have given me a condition where these four I's shouldn't come together. Now, how to do these type of questions? What do I do for always whenever you come across this kind of question? I'll put all these four I's together in a box. Okay. So let me take a box and I'll be placing all these four I's inside it. Okay, because they're telling that the four I's shouldn't come together. So I'll take a condition where the four I's come together. So I'll just consider this 4I together in the box as one letter. So how many letters do we have now? So I had 11 letters. If I remove 4 from it, that would be 7. And I just include this. So now I'll be having a total of 8 letters, including this one box. So now the factorial would be 8 factorial divided by, I still have 4 S's, so 4 factorial, and 2 P's divided by 2 factorial. Why am I not dividing it with this 4 factorial here? Because all the 4 I's has now been combined and collected together as one box only, one letter only. So now I'll simplify this. If I simplify this, that is equal to 840 permutations. Okay. Now they're asking me the situations where the I's don't come together. Now, this is a situation where the I's come together, right? 4 I's come together 840 times. So now how do I do it? I just have to subtract the value. So I have a total of 34,650. From this, if I just subtract 840 conditions where they come together, whatever I'm left with is the answer. That is equal to 33,810. So this is our final answer, students. Okay, so the distinct permutations where the four i's do not come together is 33,810. So whenever you come across any questions like this, first count the number of letters, write the factorial, and if they are repeating letters, you need to divide it by that factorial, because AA or the second A and first A, they both consider the same meaning, right? That's why we do the factorial. So that's it, students. We have come towards the end of today's class. Meet you in another session. Thank you very much, everyone. Until then, take care. Bye.